Now we'll see what is Translation Lookaside Buffer, which is also known as TLB. Okay, as discussed in previous lecture, we know that the disadvantage of using page table is the time required to access the main memory, okay, becomes double, hence the speed reduces by half. To overcome this limitation, we use Translation Lookaside Buffer, that is TLB. It is a hardware which keeps the record of a page table and corresponding frame number. Initially, system will take the information from page table. Once it is accessed, the information will be available in TLB. Hence, the data access time will be reduced. The concept is same as cache. If you remember in the very first lecture, I explained you what is cache. So what cache is doing? Cache is storing the frequently required data. Okay, so it fetches the data from main memory and keep it in the cache. So whenever CPU wants to access, instead of going through RAM or main memory, CPU will take the data from cache, which is a faster memory than RAM. So here TLB is behaving the same way. So we are going to, the system is operating system is going to put the required page in TLB. Okay, if it is not there in TLB, then only it will go to the page table. Okay, so most of the time there will be a hit, means most of the time whenever the processor search the TLB, it will find a match. So generally the hit ratio is 90%. Now you know what is the hit ratio. Okay, first system will check the TLB. Okay, TLB belongs to the system, it's a hardware. Okay, there won't be a separate TLB for every process. So there will be context switching. Control will go to the operating system to fetch the data from page table whenever it is not found in TLB. Okay, whenever there is a context switching, entire TLB is required to be flushed, and overall, that is average memory access time decreases. That is, system becomes fast because we are not accessing the main memory twice here. Okay, but in case of multiple context switching, the system fails. So the diagram here shows the same process. Here you can see the CPU. Okay, CPU generates a logical address which will have the page number, and what is D? D is the instruction offset that we have seen in the previous lecture. And there is a TLB, that is translation looks aside buffer. And why it is shown as greater than 90%? Because the hit ratio is greater than 90%. Okay, so TLB has two entries, page and corresponding frame. Okay, so first thing what CPU will do, CPU will generate a logical address. From logical address it will go to TLB, it will search for that particular page. If the entry is found, okay, it's a hit, and that with the help of that entry it will find the corresponding frame number, and then it is converted into physical address, and the information is fetched from the main memory. If the entry is not found in TLB, it will go to page table. Okay, and from page table it will go to physical, it will convert into physical address, and then we can fetch the data from main memory. Now whenever it is not getting a hit in TLB, okay, as I mentioned before, it will go to page table. Okay, that time whatever frame is accessed, that copy is brought into TLB. Okay, every time whatever is not found before, that copy is brought from page table to TLB. Why? Because for the next access, okay, it will found the entry in TLB. Okay, so this is how it works. Now we'll see the disadvantages of TLB. It requires special hardware, so the system becomes expensive. Next, at a time, it can hold only one process. The third disadvantage is initially the system will take time to fill the TLB. Till that time, system will be slow. So why this is happening? Because initially the hit ratio will be less, and every time CPU has to go to page table. Okay, so it is time consuming. Next disadvantage, in case of multiple context switching, the performance degrades. Hit ratio will be less and have to access page table, increasing access time twice. Okay, why this is happening? Whenever there is no match found in TLB, the operating system takes control. Okay, that is called as context switching, and operating system will go through the page table to get the information. Okay, so because of this the access time will increase. Okay, so this is one of the disadvantage. The solution for this is what, we can have multiple copies of TLB. It is a simple solution, but it is costly solution. Okay, the second solution is some part of the TLB can be reserved for the operating system context switching, so other process can work without disturbing previous process. Now we'll see what are the disadvantages of paging. Page table contains metadata. Now what is metadata? Metadata is the data about data. Okay. If the size of main memory is very large, then page table can be of very large size and which will occupy a lot of space in main memory, because I told you page table is a data structure which is lying in main memory, right? So this is a problem. Now how to find out the size of page table? So total size of page table is equal to number of entries into size of entry.